Hello YouTube, De-bodgery here. So this is a video for testing Hall-based throttles. So this is just a simple thumb throttle. They come in left and right. I happen to like these particular thumb throttles quite a bit because they do come in left and right. Anyway, you can use one for your regen braking and the other one for your main throttle because they come in left and right. Anyway, this is a simple 5-volt power supply that is powered off 110 volt AC. It is set to 5 volts. I've checked it on my multimeter. The black wire from the throttle is going to the V minus wire on here, essentially ground, and the red wire is going to plus V on here, which is producing 5 volts. And then of course the actual throttle wire is going over to my multimeter. And then this wire right here, that's the negative wire, black wire to the multimeter. So anyway, yeah, I'm measuring the voltage across ground and the throttle signal to test the throttle. You don't have to use a little 5-volt power supply. If you have a USB charging port, that'll work. If you have, probably just about everybody has got an old USB cable, they can cut off the end of it and strip the wires bare and hook it up to the throttle to get 5 volts. You can use a little power bank that produces 5 volts. You could use the 5 volts coming out of your motor controller. There's 101 different sources for 5 volts. The important detail is you want to make sure it's 5 volts. If you use some other voltage, say like 3 volts or 6 volts or whatever, the swing of the voltage on the throttle is going to be different. And you really want to see what it is at 5 volts, which is what your motor controller produces. So you really want to make sure that your power supply, whatever that is actually producing 5 volts to be sure. Alright, so anyway, here is the throttle, and here is my multimeter set on volts. Okay, so anyway, this is a Hall-based throttle, and they never go down to 0 volts. And they never go up to 5 volts, which is your 2 rails, in other words 0 volts or 5 volts. They always go to something a little bit more than 0 volts and something a little bit less than 5 volts. So the fact that this one is showing 0.9 volts is not at all surprising. I would kind of expect that is pretty normal. Let me turn this a little bit so it's, there we go, so get a little bit more light on it. Alright, so anyway, I'm going to start moving the throttle. And this throttle is, by the way, defective. It has a problem. And you can see that the voltage swing is increasing. But the problem with this throttle is not the Hall. It's actually a loose wire. And there goes full voltage. So as you can see, it didn't go up to 5 volts. It went up to 4.25 volts, which is not unusual. And I'm going to start letting off the throttle. Actually, that time it worked just fine. Did not give me any trouble at all. So now I'm back down to no throttle. And I'm going to go back up. What I've seen multiple times now on my multimeter is I get almost, yeah, there we go. You saw 4.22 or 5.22 volts. Yeah, there's a loose wire inside this throttle, and every once in a while it kind of like shorts against the throttle out wire. Yeah, you saw 5.11 volts. But yeah, I need to take the throttle apart and fix it. And that was the whole point. I noticed that when I was riding with this throttle, that you know, there would be like this right near full throttle position, and it's because of that little problem. Going all the way up, yeah, there we go, 5.16, and then it settles back out to where it really ought to. So 4.25, 4.3, 4.15, something like that. That's pretty typical for Hall throttle output at full throttle. That's not unusual at all. And then letting it all the way back down, 0.9, 0.8, 0.7, that's pretty typical too. Most motor controllers can handle that voltage swing and still determine, you know, minimum and full throttle just fine. So the Hall, in my opinion, is working fine. It's just that there's probably like a loose wire in here that's creating that momentary glitch right up there at that 5.3 volts or whatever, right there at the top. But anyway, that's how you diagnose your throttle. Just hook it up to your multimeter. You need a 5-volt power supply that you can power the throttle. And you're going to take the throttle out and plug it into your multimeter on voltage. And you're going to go through the full swing of the throttle. So what you didn't see on camera a second ago, because we're looking at the multimeter, is I was just going like this. And then letting it go. And just slowly incrementing, and watching the voltage on the multimeter to see what I was getting out. But if you see a nice progression of voltages like that, your throttle is working okay. But if you see like that jump in there, you know, that was right up there towards the top of nearly full throttle, well, then the throttle's got a problem. You need to figure it out. Yeah, a lot of times you'll see a Hall-based throttle that is blown. And I want you to notice over here. So this says volts, V, doesn't say MV for millivolts. So if your throttle is putting out millivolts, it's not working. Just throw that out there right now. Just assume that your throttle is broken, and you need to either replace the Hall inside or get another throttle. Your throttle should always be putting out voltage, okay, not millivolts. Millivolts is thousandth of a volt, and your motor controller will not understand what that is at all. So, like this is 0.9 volts up to basically 4.25 volts. That's pretty normal functionality for a Hall-based throttle. Minus that little glitch that does up there nearly at full throttle. But yeah, the voltage swing is fine. It's just that little glitch in there I gotta fix. And then this thing will be working just fine again. So, this is De-bodgery saying, I hope this helps somebody. That's how you diagnose a Hall-based throttle to make sure that they're working correctly. You just need a 5-volt source and a multimeter that you can attach to the thing as well so that you can check the output voltage of your Hall-based throttle. Well, I hope that helps somebody. Take care. Stay away from the damn virus and all that. Keep well. Bye.